Hi there, welcome back. This is a rather unusual start to the third video in a series of restorations. I'm talking about the Grundig 2147. I decided to film this intro because I've got some goodies. I've got some Santa Claus stuff that arrived, and which is something I didn't expect because shipping has been a little delayed lately, but it seems that it's still getting through, and fortunately it got through before Christmas. And what I wanted to actually do a few call outs here. One is, I want to thank everybody for the very, very kind comments on the reveal video that I published. I think it was yesterday. I'm really quite flabbergasted with all the comments. Thank you all. It was very nice of you. Very nice indeed. Now, I also want to just do a shout out to PCBWay, who have sponsored quite a few of my videos this last year. I started using their PCB services for the projects that I do, and I've been very happy with the results. And this time they sent me something unexpectedly. So it's goodies, which I've already opened. So basically, they've sent me some Christmas gifts. These two bags are empty, and I'll show you in a second why. Some stickers, and then a few of these PCB rulers. And these are quite cool because they give you all the gauges and a whole lot of, well, yeah, see for yourself. Just about every single footprint you can imagine. So you get a very good reference to sizes and how you're going to do the layouts on your own PCBs. And just for good measure, there are 4 different colors. These are always welcome. And these pens are great. They are. But I want to thank them for the support they've given me this year. It's made a huge difference to what I could do on my channel. And if it can help somebody else do some more interesting projects, then I'm glad to be part of that. So thank you, PCBWay, and if you want to go and have a look at them, they're having the Christmas sale at the moment. So visit the website. They're giving away a lot of stuff, a lot of vouchers, a lot of discounts. The prices are amazing as usual. The delivery times are quite amazing. Thank you, and I'm going to just show you one more thing. The 2 bags that I mentioned, they've now got pride of place on the top of the Christmas tree. These are PCBs that somebody had prepared or designed, and they sent me one of each. So I put them on the Christmas tree. They look quite good, actually. Something else which came up, which is this company, ELV. And if you don't understand what the text means, it's HQ, high quality, I believe, stereo, UKW is FM, proefgenerator, which is test generator, sub 3. And this is actually a kit which this company sent me, ELV from Germany. And what this is a stereo FM signal generator. And once I've built this, I can generate FM signals, FM stereo signals, with a known output level, known frequency, known deviation. It's probably a lot more advanced than I need, but I'm hoping that this thing will be able to do the job that I haven't been able to do and that I've been doing with this guy. So if you can't afford a, what is it, an Agilent HP8657 or something, and you don't want to be ridiculous with something like this thing is great. So I'm hoping that if this thing works out, I can produce a video in English, and some of my subscribers might be interested in buying one of these things. We'll see how we get along. All right. Well, for now, I want to thank you all once again. I want to wish you a Merry Christmas and a Happy New Year. Happy holidays for those who don't celebrate Christmas. Once again, thank you for a wonderful year on the channel. Everything else is debatable. And may the next year bring us all good stuff and good riddance to this thing we do not want to mention. Once again, thanks, and stay safe, and I hope you enjoy this next video, which will start, as usual, with Hi there, welcome back. You get to hear it quite a few times this time. Hi there, welcome back. Welcome back to the third video in the Grundig 2147 tube radio restoration. I've made some progress. As promised, I went in the order that I'm accustomed to, which is sort out the power supply and then go to the power amplifier, then the preamp stage. And the whole idea is to get the audio going through from the back, which has a tape input, which I'm using as a line input, which seems to work pretty well, all the way through, and to ensure that the entire audio stage is fine. Well, with a few capacitor changes, checking all resistors, checking all contacts and switches, cleaning switches, I think we're there. And in this video, I'm going to show you the result on the scope. I'll be using the web management on the Siglent Scope, which allows me to do a direct screen capture as opposed to filming the oscilloscope. And we'll be able to see what the result is, what kind of clipping characteristics we have, what the headroom is, how much power we can get out of it, and also what kind of frequency response we're getting on there. And if you recall, this thing has got a bit of a loudness function on the volume control, on the volume pot. I believe it's called the psychological tone control, and it gives you a bit more bass at low frequencies, so we'll be able to see how that comes out. I'll be doing that with using the VisualAnalyser software, which allows me to do a Bode plot very simply. And it's not very accurate, but for this purpose it serves quite well. Then I want to show you on the schematic how far we've got, and we'll see what else we need to do. This entire radio has been cleaned. I've used a lot of isopropyl alcohol and cotton swabs and everything else, but all the knobs, all the piano keys were cleaned up. Things cleaned up pretty well. There's nothing broken, which makes a hell of a difference. Any surgical tape that they put on here tends to dry and looks really crappy, so that all gets replaced. Knobs are shining, piano keys are cleaned, including between the keys, which you sometimes forget. The chassis itself looks great. It didn't take much, it just took a bit of alcohol. Nothing too dramatic on there, no rust, nothing of the sort. Components cleaned out, so this thing is looking quite spiffy, and as far as cleaning is concerned, the actual chassis is done. We'll then just have to look at the cabinet and see what we need to do there. But let's get on with this and feed a signal into the back, into the DIN input at the back. I'm using the tape in, as it were, and see what we get on the scope, see what the result is. So I've got a 1 kilohertz signal coming in here. I've got 100 millivolts RMS. I'm going to switch it on and we'll see what this looks like on the scope. Perfect. We've got the screen capture. The screen capture makes it a lot easier than actually filming the camera. Now I'm going to put the volume up. And there we go. We're starting to see something. Let me change the... There we go. We've got, what have we got there? 700 millivolts, 800 millivolts RMS. Beautiful sine wave. Let's go up and see where the clipping happens. I've got 100 millivolts coming in, so I may have to increase that. Let's see if we start getting clipping anytime soon. Not yet. Right, it's now at maximum volume. And I've got 2.45 volts RMS. I'm going to increase the input to 200 millivolts. Aha. All right, there's our clipping. So let me go down. Okay. That's starting to look quite good. There's still a little bit of rounding off of the sine wave bottom and top. See that? So this would be a 2B sound. In other words, if you went down, you'd get less harmonics. Over here, you would have some harmonics. And that's sort of what gives it the tube sound. But if you look at that, that's about, what's that, 3.2 volts RMS. That's probably the limit before clipping, because after that it starts getting a little ugly. So 3.2 volts RMS, square that, 10 divided by 8, we're getting about, I'm using an 8 ohm dummy load, so we're getting about 1.25 watt. And this is my question here. 1.25 watt is lower, much lower than what they say on the on the data for this radio. And I found that in most radios that I use, that I test, I don't get the power that they suggest we should get. And I really don't know why. It's either because these EL84s are tired, or there's something that I have not figured out yet. But it's never what they tell us it's going to be. It's always lower. But that's what clean power would look like. About there, 3.2, 3.3 volts RMS. If I change this to 4 ohm dummy load, that's what happens. And if I go up, it still distorts there because the distortion is happening on the primary side. There's 8 ohms, and not so much on the secondary side. So the speaker they suggest you use, or they've stated in the datasheet, in the schematic, is 5.8 ohms, if I'm not mistaken. So this thing is sort of, one is halfway between the other. I've got 4 and I've got 8 at the moment. It's 8. But that, my friends, is our result. And it's one hell of a nice sine wave. This thing is working beautifully. Now, there's something a bit strange here, and this is something that I want to show you. I'm going to leave it at that level, and I'm going to set the level to about, let's call it 2 volts. There we go, about 2 volts RMS. It's a bit too much. 2 volts, 2.1. Now, watch what happens when I start increasing the frequency. I'm at 1 kilohertz. That's now 2 kilohertz. 3, 4, 5, what is that? 6, 7, 8, 9, 10, right? Now, if I go up in volume, put the volume on max, and if I go down, you see what happens? We get our peak there and it starts distorting down here. So what I'm going to do is change the amplitude back to 100. I don't want distortion. And I'm going to increase the volume to max, and I've got the tone control on max. Okay. And now I'm going to start increasing the frequency. 1 kilohertz. That's 3, 4, 4, 5. That's 7. You see how it goes up there? So we've got ourselves a hump. There's a hump on the upper mid-range. And I'm not sure, I know why this hump changes depending on what the volume level is, but I'm not sure why this hump exists. And this, my only thought is that it's happening because of this capacitor here. This capacitor is the one that's on the schematic across the primary. Now what this is doing here is to prevent high frequency oscillation. So it basically shorts out very high frequencies, and it doesn't allow this thing to go crazy, run away with huge oscillations that you could have and not hear, that could in fact damage the amplifier and the output transformer and all that stuff. But this is also cutting off high frequencies. So high frequencies that are being produced across that inductive load, which is the primary of the transformer, effectively get shorted through. And you want that because you don't want this thing to run away. But the thought was this thing is also effectively creating a tank circuit between it and the primary of the transformer. So perhaps at those frequencies, what's happening is that you're getting a sort of a tank circuit effect, and this thing is going into, well, I suppose the range that this thing is resonating, and therefore you get that hump. Now, I just thought this might be on purpose because you've got a very small speaker effectively, and the frequency range of the speaker is probably not that high. So one way to compensate that is to actually make it boost the certain frequencies and get the effect of more highs coming out of the speaker. That could be it. So you've basically got an equalization curve that they've applied on the output to compensate for the type of speaker you've got. This 4.7 nanofarads is actually quite high. I've seen quite a few in these radios. I think usually they're smaller if I remember correctly. Maybe wrong. But that could be the reason. I'm just sticking to that story. That's the one that makes sense for now. the fact is this thing works quite well, and I'm now ready to go the next step, which is to follow through and see what else we need to do. But firstly, I just want to show you on the schematic what it is that's been done. This is the part of the schematic that we've just been talking about, and as you can see here, what I've done is I've taken the audio, I've taken the schematic or the circuit all the way from the input, which is this DIN plug here, and it goes through this set of switching, and then that set of switching, and then that set of switching, and it gets to the top of the volume pot, and that's the goal here. Now the reason there's two sets of switching is because to activate pickup input or tape input, you have to actually push down on long wave and on short wave simultaneously. So this all gets through to the top here. Then we've got the volume pot over here with a feedback network that doesn't allow the bottom of the volume pot to go all the way to ground. There's a 560 ohm resistor here. And what that does is it allows it to use the feedback from this line here, which comes all the way back here to the speaker output. So it takes the output and it actually is subtracting it. It's a negative feedback that happens at this point. And the feedback is only for certain frequencies depending on this sort of RC network and switch network that we have over here. As you can see, there's a resistor here, which by the way was the wrong value in there. The original that's in there, and it was the original, is not a 56K, it's a 6.8K. It measures just fine, so I left it in there. But you can short it out. So this signal could go straight through. And if it went straight through, it would just find that resistor, but it would have this to ground. So this is a whole setup here that tone shapes the feedback to give you the desired sound at the end. And the two choices you have are music and speech. Okay, that's the two piano keys you have on the front. And I believe one of them activates this one of them activates that one. If that one is off, in other words open, it means that there is no leakage of high frequencies to ground. So, you know, that could be to give it more speech frequencies. I'm not sure exactly which one it is, and I'm not too interested. But that's the whole idea. So this feedback comes here to this resistor, and then you've got the bottom of the volume pot, which then takes a signal through the wiper, from the wiper, through that coupling capacitor, which was changed, into the preamp triode of this EABC80. This tube in this particular case is being used just in the audio section. The diodes here are for this side of the circuit we're going to look at later. So that preamplifies it, and then it gets to here. Then you've got a tone control here, which is basically a variable resistor that bleeds off audio to ground, or to this point, through that capacitor, which was also changed. This thing here is just a bit of supply regulation, smoothing. What else do we have here? And then of course it gets to here, and it basically drives the EL84, and that drives the speaker or the transformer. This capacitor here, this 4.7 nanofarad, was the film cap that I measured in line there, and I showed you that. It was in perfect condition, just as well, because this is probably the most difficult one to remove from there. So I was fortunate. Well, here we've got a tape out. So this point here is where audio comes from the radio sections, so FM or AM stations, and that comes through this 2.2 meg to this point. So between 1 and 2 you'd have an output to a tape recorder, which we don't use anymore, but it's there and it's been checked. And other than that, well, yeah, this is what we have. Now, one thing I did do is, in order to try and explain why this tube was not amplifying enough, I did measure voltages on here. I got 220 volts on there, on the grid, on the anode plate. The screen was 200 volts, screen grid, 200 volts. And over here, I measured 5. Now, when I put this thing into a simulator, and you can get them online, you get load line calculators and so on. When I measure these, when I put these characteristics in, the anode voltage, screen voltage, and the, what else do I put in? And the screen current, or rather the cathode current, which in this case is about 36 milliamps. What it tells me is that this voltage here should be about 6 volts. So I think this tube is a little bit tired, and that could be the reason why I'm not getting the power that I expect from there. The other thing that we have is that capacitor that I mentioned on the primary of this audio transformer. This thing could be creating a tank effect between it and the inductor. This is basically a capacitor inductor. In parallel, you get a tank circuit of sorts, a resonance circuit. And I mean, I don't want to go into calculating the resonant frequencies. It's going to be too complicated because you've got impedance down here, you've got it down there. So it's not quite that simple, but the effect that we're getting is that this thing is actually creating a hump in the upper mid-range frequencies, just below the high frequencies. As you can see, there's not that much. 9 components that effectively needed to be looked at or changed. But these are the most important components. This is your audio stage. Everything that comes from the radio or from the pickup needs to be amplified, and it's important that it does so correctly, that you don't get clipping, that you don't get oscillations, that the frequency response is fine. And what I did do is I connected the output, the speaker output, into the PC sound card, and I used a software called VisualAnalyser. And what it allows me to do is to do a Bode plot. The scope function is basically a sound card oscilloscope, but the scope function doesn't interest me at all. I've got my brand new Siglent SDS1204XE. I love it when people say the whole title, and I'm doing the same thing. But what it does do is it allows me to do a Bode plot, a frequency response plot, by sending a sweep signal on here. So I send a sweep signal from my signal generator, 20 Hertz to 20 kilohertz. It goes through this whole thing and it comes out the other end. And the result that I got varies depending on the volume control level, not the amplitude of the signal, but the actual volume control level. And the reason is obvious. There's this thing over here, which at a certain low volume level bleeds off highs and makes the entire sound like it's more bassy. It's a loudness control. And we can see that. And if I show you now the result of this thing at full volume, and as you can see, it actually goes quite far up and it starts dropping off. Then if you take the 25% or the 50% level, I put this at about halfway, not in value, but in physical halfway, half a turn. And we've got a different result. As you can see, the cutoff is happening sooner. It's actually cutting off frequencies much earlier than it was doing when I had this in full volume. And then when I take the volume control and put it at about 25% rotation, the effect is even greater. So if you look at this, you can see that the entire sound is more bodied. It would be more bassy, less treble, and sort of psychologically louder, I guess. That's open to debate. All right, enough yakking. I'm going to go away and keep quiet for a while, do the recapping of the rest of the radio. This will be the radio sections, FM and AM. And when I come back, hopefully I won't have much of a problem. I'll be doing an alignment. I'll be seeing what that coil needs. And basically, I think this thing will be nearly done. So thanks for watching. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And I'll see you soon. Bye for now. Stay safe.